Hello and good morning. I am Gwen Calimoso from ABCD News. Our highlights for today's news report are about plate movements. So now, let me call on Raya Berlan for the first news report.
Thank you, Gwen. Did you know that plate movement causes earthquakes, formation of volcanoes, and the formation of mountains? Each tectonic plate is free-floating and capable of autonomous movement. Earthquakes and volcanoes are caused by movement of tectonic plates along fault lines. The various tectonic plates constantly shift and interact, reshaping the Earth's outer layer. Now, let's pass the news report to Ben Casador.
Thank you, Raya. So first, what are plates? Plates are large slabs of rock that divide Earth's crust and move constantly to reshape the Earth's landscape. Plates are also rigid bodies of rock that essentially float atop a region of partial melt called the asthenosphere. The plates comprise the lithosphere, composed of the crust, which is the rigid outermost layer of the Earth, and the solid portion of the upper mantle. How about you, Marian Cortal?
Thanks, Ben. So what is plate movement? When the heat from the radioactive processes within the planet's interior is sometimes away from each other, it is called plate movement. Plate movement is thought to be driven by a combination of the motion of the seafloor away from spreading ridges due to variations in topography. How about you, Rick? Do you know why plates move?
Thanks, Marian. Well, let me tell you why do plates move. Geologists have hypothesized that the movement of plates is related to convection currents in the Earth mantle. Convection current describe the rising, spread, and sinking of gas and liquid or molten materials caused by the application of heat.
Though scientists have already researched how our Earth will look like in millions of years through digital simulations, we can't accurately hypothesize that the Earth's continents will regroup to a supercontinent in detail. There is no accurate data that points to what the supercontinent will look like. We can tell if one plate will suddenly change direction.
Based on analysis, the history of the supercontinent Pangaea will continue as the plates will fit together, then split again after a long time, and so on and so forth. Some continents will join together and then break apart, forming various landmasses, and the cycle will repeat again. This is known as the supercontinent cycle or Wegenerian cycle in honor of Alfred Wegener, who proposed the theory of continental drift. It is the constant reconfiguration of the Earth's crust that happens every 300 to 500 millions of years, which leads us to hypothesize that a supercontinent will form in another 100 millions of years or so.
I see. Now there's no way that we can theorize what the new supercontinent is.
It's not entirely true. Thanks to different studies in paleogeography, the study of how the physical face of the Earth has transformed over time tells us that there can be many variations of supercontinents that can be formed if plates continue to move in the future. Though researchers have already observed different theories of how the supercontinent will look like, yet it is still impossible to predict the full extent of the effects of climate change and human activity to the future of the continents. The supercontinent cycle is already a hypothesis we can make if plates continue to move in millions of years. But to support this theory, we will make use of the evidence that the supercontinental cycle is happening in the past and will be expected to happen in the future.
The supercontinent cycle has been greatly observed by researchers for years, and now they still continue to do so. When we're expecting changes in million years due to the movement of crustal plates. Wegener continental drift theory served as the first evidence of this cycle. As we know, Pangaea is a supercontinent that broke down million years ago, that turned into continents that we are today. Supported by the evidence such as distribution of fossils, geological features, and latest GPS track. Researchers then have come to recognize the supercontinental episodicity that had been taking place in our Earth's history. Recent study from 2021 in Curtin University, led by Dr. Liu, suggested that 2 million years ago was the start of the supercontinental cycle, in which they believe that the start of an era of supercontinents and its movements. The rest, 2.5 billion years in early Archean, was composed of protocontinents or supercratons. We can call continents yet, and these cratons have still exist to this day for scientists to conduct studies with the help of paleomagnetism, which calls us our second evidence. Marian?
Got it, Chief? Paleomagnetism is the study of ancient pole positions and make use of remnant magnetization to reconstruct the direction and strength of the geomagnetic field in the past. We can precisely reconstruct Pangaea by simply reversing the direction of seafloor spreading until the continental margins meet. However, because there is no intact seafloor older than about 200 m, we must use other approaches to reconstruct older supercontinents. Of this, only the paleomagnetic approach is quantitative. We make use of rocks magnetizing the Earth's magnetic field at times in the past, which carry the position of the magnetic poles, known as polypoles, the declination and inclination that can be used to determine where the rock was when it acquired its magnetization. When a rock forms, it may acquire a magnetization parallel to the ambient magnetic field, referred to as primary remnant magnetization. Information about both the direction and intensity of the magnetic field in which a rock formed can be obtained by studying its primary magnetization. The most important minerals controlling rock magnetization are magnetite and hematite.
Take this diagram for example, rocks X, Y, and Z. We observe that rock X in the modern-day magnetic equator has a high inclination, or the angle between the magnetic field direction being far off the field. It points out that this rock must not have originally formed there. It must have formed originally close to the magnetic south pole. Similarly, rocks at location Y and Z have very low angles of inclination, but they are located in high altitudes close to the poles. This tells us that when they formed, they must have formed close to the magnetic equator. This leads us to conclude that continental drift has been happening since. Recent studies have found existing cratons ranging from 3.4 billion years old, like Amazonian craton, has been thoroughly studied, by which they hypothesized that it was part of a supercontinent before Pangaea, which we call Columbia, that proved that a cycle has been present in history.
So our third evidence is the Wilson cycle by Tusu Wilson. It is the idea that oceans close and later open along firmer structures has since become a fundamental concept in plate tectonics. There is, however, a widespread misconception that the Wilson cycle is synonymous with the supercontinent cycle. The Wilson cycle refers to the history of a single ocean basin and includes the stages of continental rifting, which is the Rift Valley stage, early oceanization, the Red Sea stage, divergence in a mature ocean, Atlantic stage, ocean basin convergence and closure, which is the Pacific stage, and continent-to-continent collision. The Wilson cycle is not, however, a cycle sensu stricto, as not all the steps were required. It may abort after the first or second stages, and it may span a few million or hundreds of millions of years. The supercontinent cycle is conceived as a geodynamic mechanism that may explain a long-term behavior of the entire Earth and involves all of the Earth plates, both continental and oceanic. In addition, whereas there is no hierarchical relationship with the Wilson cycle, a particular supercontinent cycle may involve multiple Wilson cycles, both partial and complete.
Mantle convection current, the third evidence how the mantle convection or convection of current has affected the Earth's crust of plates throughout the years. A method called seismic tomography has been used for years To now image the Earth interior three dimension using seismic wave from natural earthquakes recorded at the station located at or near the surface around the world. And this includes a mantle convection seismic thermography, help us to create 3D simulation that led us to a better understanding of the thermal and mechanical coupling between the mantle convection surface and motion. Prediction of the configuration of the next supercontinent. Let's look at the diagram. We have this evidence of the continental drift in our hands for as long as nearly 50 years, and we have seen causes plates to move. Can also see Earth subducting plates through this. With this, we can safely investigate a future continental motion and driving force of continental motion below the Earth's crust, providing numerical simulation models global mantle convections. We wouldn't have this evidence weren't for recent advances and breakthrough of the capable seismologists in 1970s.
Fifth evidence, radiometric dating. Radiometric dating calculates the age of geologic materials of rock that have been left in centuries. A radioactive materials of rock that have been left in centuries. There, the paleontologists and geologists have been trying to prove that the supercontinent cycle have been happening in the past in the study of geochronology. Through this, they have come to investigate rocks that they believe have been dating for billions of years, but how they do it? By using certain elements such as potassium -40, as they can measure the radioactive date of a rock about 1.25 billion years old, considering its half-life is 1.28 times 10 to the 9th power. A half-life is the decay rate of half of the atoms in an isotope. And depending on the radioactive element, like uranium -238, for example, can have a half-life about 4.5 billion years old. Geologists have studied sedimentary rocks and rock remnants have been patched up to provide evidence of geologic history up to 2.5 billion years ago, like the Jurassic Age 150 million years ago, Archean and Proterozoic Age 2.5 billion years ago. Fossils left by creatures and rocks have been studied throughout present continents and came to conclude that they were on the same age. Tell us that continental drift have been happening. Not only that, but the evolution of creatures, which tells us there have been a difficult eras, and both rocks and fossils have made proof that supercontinent cycle is real.
Now we know the evidence of the supercontinent cycle. Now we have to see what effects it will have on our planet in the future if plates still continue to move in the cyclic process of forming and breaking down supercontinents.
Effects if plates continue to move in the next cycle. Things are expected to change, especially the climate and people's lives. First effect: changes in sea level. Sea levels may change at different rates and amounts in response to different phases of the supercontinent cycle, and the sea level changes are closely related to climate. The global volume of the mid-ocean ridges can change dramatically either by increasing the total length of ridges or changing the rate of seafloor spreading. Continent-to-continent collisions, such as those associated with supercontinent formation, can lower sea levels by reducing the area of the continents. When continents collide, mountains and plateaus are uplifted, and the amount of material taken from below sea level to higher elevations no longer displaces seawater, causing sea levels to drop. Second, climate change. Rapid movement of tectonic plates causes increased volcanic activity, which releases more carbon dioxide into the environment and warms the climate. The tectonic plates, however, have the opposite effect
as they slow down. Additionally, we will observe an increase in length of the ocean ridge system during the supercontinent breakup would also promote mantle degassing and release of CO2 into the atmosphere. The rising CO2 levels and elevated sea level generate warmer climates. Thus, the Earth's climatic evolution has been tectonically punctuated by alternating intervals of greenhouse drowning and icehouse emergence. We can expect a change in climate conditions by then in the process of supercontinent amalgamation in the near million of years. Third, changes in salinity of seawater. The launch of the supercontinent cycle reduced ocean salinity to about 50% greater than the modern value. This ocean salinity level kept the ocean sufficiently starved of soluble oxygen to limit marine life to microbes. Until recently, scientists assumed that the only factors operating to lower open ocean salinity were precipitation, melting of glaciers, and the creation of evaporate basins through the supercontinent cycle. This may affect the life of aquatic organisms in seas. Fourth, changes in human life. In most cases, the oceans themselves have an impact on us by causing earthquakes, which harm or kill some of us, and also damage some of our houses. Volcanoes, hot springs, and other geological events are also caused by the underlying processes powering the movement. Some of these phenomena are of course highly dangerous. In future generations, people will most likely live in harsh environments owing to climate change due to continental drift that also may include human activities. Fifth, changes in biodiversity. As we are expecting a supercontinent, we expect a new environment that will greatly affect life here on Earth. In a new environment, we can expect a change in our biodiversity. We may experience mass extinction of some species following the change in climate, and other changes in our biogeochemical cycle. Other than that, there will be a loss in human life by then, making less human activities that will take on a generation of wildlife animals.
This made us realize that we will never know what will happen in the future since we are certainly dead by that time. We wouldn't experience extreme weather, change immunity, culture, because we are living in the present where we're studying what? Change in unity, culture, because we're living in the present where we're still divided by seas. A 98-kilometer asteroid might hit the Earth and wipe out all life, and we humans were not going to witness such changes.
The supercontinent cycle hypothesis is the elegant mechanism for explaining the Earth's long-term tectonic cycles and time. Geodynamic behavior, however, the limitations of the extent of geological record make it difficult to provide accurate 2 to 4 billion years of chronology for Earth's supercontinent cycle will permit many interpretations of major events, including the possibility of supercontinent cycles does not exist as currently advised.